Welcome to the video tutorial for exercise number 7 of the APM exercise set. The first thing to do with this exercise is to check for the units, as always. Because we're not told anywhere that this is inches, it is safe to assume that it's millimeters. Also, when we look at the numbers, it makes most sense that it would be millimeters. So I'm going to start with a sketch, in this case on the front plane. And I'm going to make this profile here. So I'm going to start out with a line, starting from the origin to the left. And then I'm going to press A to get a tangent arc, like this. Then press A again to get another tangent arc, like so. And once more, to get a tangent arc like this. And I'm just going to continue with lines. All of these edges, or nearly all of them, have to be tangential, so make sure that you include that relation from the moment you're sketching, just for ease. I'm going to make a tangent arc here, like so, followed by a straight line, which is also tangential here, and bring it somewhere below the origin, and then to the right, make an arc, a 90-degree arc for that matter, like so, followed by a line. And then I'm going to make another arc, but I'm going to make it center point because it's easier that way. And I'm going to make the center point somewhere to the left of the vertical line I just drew. So like this, bring it all the way here, followed by a line. Another center point arc, because I want these two to have the same center. Bring it over like this. And then follow that with a line to the origin. Now, this line that we close here should also be horizontal. So I'm going to set that relation first. And then that, I'm going to make this and this tangential, as well as this and this must be tangential. And then it does seem like that's all the relations I need at the moment. Make sure you have tangential relations in this point here. If you don't, just control click one, control click the other, and set tangential here. With those drawn, I can draw the holes are going to be in this profile. So there's one here that's concentric with this larger arc. We move this a little bit out of the way. Then another center point arc with the same center as this arc, which is this one here. Roughly correct, doesn't have to be too accurate just yet. Close this with a line, like so, like this and like this. And in another circle that is also concentric with this arc here, so that would be this point. And that's, well, we still need to set some relations. So, for example, this and this must be parallel. Same thing here. These two must be parallel. I'm going to move this slightly out of the way. And this one, well, we're missing one line here. It's a construction line, actually, that helps define the geometry of this line here. So if you look here at this line that goes through, well, from the arc through the center of the circle and to this line here, the joint is perpendicular. And that perpendicularity is what is going to allow us to define the direction of this line. Otherwise, we couldn't define, say, the angle of the diagonal. If it's pointing like that or like that. So for that, I'm going to make a center line going from the midpoint here and to the line. And I'm going to make this center point, well, in this case it's already coincident, but if you draw it and it's not coincident, make sure to set those coincident, and then make this and this, this line and this line perpendicular. Now I also want to make sure that these two lines, I made them with the same center, so it should be already true that they are concentric, but I'm going to set the relation nonetheless. And Well, actually that's just it, just concentric. And with that, we should have all our relations done. So we can start dimensioning. I would suggest you start dimensioning this side first, because then we're going to use this side as a reference for this side. You can see that here, first we go from the origin, we dimension here, and then from here, we dimension this way. So we're going to start here. So, first I'm going to make the distance between these two 10 millimeters. Then the same here. Likewise, these two are separated by 10 millimeters. 5 millimeter radius. Excuse that. Up here we have 6 millimeters. We're given this angle is 140. And the angle between these two is 22 degrees. Also, we're told that the radius of this arc is 20 millimeters. This here has the diameter of 12 millimeters. And we're told that the separation between this line and this point, the center point of the circle, is 12 millimeters. So click the center point and the line, and that should be 12 millimeters. And notice we're told, we're given the direction or the separation in the direction perpendicular to the line here. Other than that, we're not given any other dimensions for this side other than the location. So that would be, well, we're told this here, and we're also told, well, these relations, these dimensions that give us the position, like how far from the left this is, but the shape itself should be almost completely defined now. So I'm going to define the one that we saw at the top, 70 millimeters. I'm going to click with the one arc and then the other arc. And I'm going to set that relation, that dimension there. And notice, this is not the dimension we're actually looking for. We're looking for the longest dimension possible between this arc and this arc. And the way we do that is that, having set the dimension here, you can double click it, just accept, and in the leaders tab, if you could go all the way down, you can select where you're measuring from. So in this case, I want the max distance in both cases. So it would be, for both of them, I set max, so we get here the maximum possible horizontal direction. And that we can set again by double clicking to 70. Likewise, we're told from the origin to the angle that we measured here, we have 82 millimeters. We're also told, well, this radius here, I forgot almost, is 32 millimeters. And you see here 32 millimeters of radius here, but we're told that the center of this arc here, of the 32, where we're measuring the 32 radius from, is 8 millimeters above the line here. So that would be between this line and that, we have 8 millimeters. And it's also probably going to be useful to set the separation between these two, and that's 12 if I'm not mistaken. Indeed, here we see it's 12. So if I drag this a little bit into shape, that looks more correct, but we still need to define a couple of things. So I think the last one we need to define this is this here. So again, from the arc to, in this case, the origin, notice we're not given the dimension we're looking for. That's fine. I'm just going to accept for a moment. And when you accept, you get the option to change this here. And again, set it to max. So when you use this, you get the maximum possible distance between the arc, any point on the arc, and the origin, which is our reference. And that should be what we want. Well, you can change the value here. We were told it's 132 millimeters. And now with that, the whole side here is completely defined. Also, now we can use this to define this side. Well, we're told that from the bottom here, let me show you, from the bottom here up to the very top of this circle, we have 102 millimeters. So that would be from here to the arc. And again, we have to do the same thing. Change the options to the maximum distance, in this case the maximum vertical distance, and set that to 102. Now we're also told that from the center of the circle, this circle here, to the maximum point of this arc, like again the maximum length from this arc, we have 212 millimeters. So I'm going to select the point, I'm going to select the arc, and once more accept, go to the leaders option, set it to max, and set the value that we actually want. That would be 212. Else, well, we need the radius, the outer radius here, which is 15. And the inner radius, that's, well, diameter 13. And this here has a radius of, oops, excuse me, that's a radius of 18 millimeters. And now we're fully defined. So I've made most of this profile. I haven't done this little lip here at the bottom because that has a more complex shape. I'm just going to extrude this for a moment. I'm going to get a basic shape from which I'm going to extrude and cut some other things. So in here we're fully defined. Make an extrusion, and in this case, because you see the part is symmetric through this plane or this line here, right? So I'm going to, and the holes that we draw later, like for example this one, which is this gap here, that is also symmetric around this line. So I'm going to make everything mid-plane, meaning in the case of the extrusion. So you see, if I select mid-plane, I'm extruding from the plane here. It's kind of hard to see, but I'm showing it from the top, from that plane, both ways. A total of 10, so 5 this way and 5 that way, but we don't want 5, we don't want 10, sorry, we want, in this case here we're told this is 60 from this face to this face. So if I make this 60, that should look roughly correct, and it does. The next thing is going to make the gap between these two faces, because right now they're connected as one single solid. And for that, I'm going to start a drawing on the front plane again. And the first thing is to make a center point arc, which is basically the same as this, but extended. And you'll notice here that we're giving here the dotted lines that go from this edge here to this edge here, and they're coincident with the arc here. That means it's the same center and the same radius of arc, but just extend it until it reaches the two edges. And to make that, I'm going to just hover the mouse here so that I get the center. I'm going to make it slightly larger at the moment, and I'll show you why. I'm going to bring it from one edge to the other edge. Okay, so I'm going to click the arc I just drew and control click the other arc I wanted to be on top of, and I'm given the co-radial option here. So click that, and now we have the same radius, and because we drew it concentric, we don't necessarily need to add the concentric option as well, but if you want to, that's fine. It's just a bit redundant, but it's not wrong. Other than that, we see that the cut just follows the same profile. So I can just convert entities, and what convert entities does is that it takes an edge or just a line or anything from a body or a previous sketch or something like that, and it copies it onto the sketch you're working on right now. So in this case, actually, I only need the arc here. I need to convert that one, and you see it's already dark, but it's fully defined because it comes from something that is already fully defined from our previous sketch that we did fully define, and it's just a copy of it. And to end that, I'm going to extend this a line here to connect, and the same at the bottom from here to there. And that should be a closed sketch, and also the edges are all dark. You see it's all fully defined because, well, this was already fully defined. This we defined with reference to the body, and then this is just connecting two things that are defined, and it's also defined. So I'm going to make an extruded cut, and I'm also going to make the extruded cut mid-plane because I want it to be basically symmetrical from here to here, right? At the moment it's not, but if I select mid-plane, then it is. Now I have to set the correct width of the cut, which is 32, we're told here. And that's correct, right? It's symmetric from the middle of the thing. And it looks the way it should. So we can be confident about that. Then we could do something similar on this side. Now on this side, you'll see the head cylinder here, if I can call it that, is longer, or it's wider from the top than the rest of the body. So I'm going to make another extrusion to, well, bring that cylinder all the way out as it has to be here. So again, from the front plane, I'm just going to, well, start a new sketch, and I can just convert this circle here to it. And then I'm not going to convert the larger circle because you'll notice this is not a circle, this is an arc, it's not complete. And I want to make a circle actually. So I'm going to make a circle from the same center and make it slightly larger so I can easily just select this and, well, the one previous was already selected as well, and make them co-radial, meaning they have the same radius. And there you have it. Now that's fully defined. And again, it's fully defined because it's referencing something that was previously fully defined. So I can extrude that again, mid-plane. And in this case, we're told from one end to the other, it's 135. So we can just set that here, 135. Like that, and accept. And it's looking closer to correct. Now we also have a bit that is cut out from that cylinder, and we can see the cross section of the cutout. It's a bit difficult to see, but there's a few things that you should pick up on. First of all, the angle here, that should be kind of obvious. 5, this 5 refers to a distance from the center to the edge here. That would be this edge here, this face. They're not in line, but they're like offset by a parallel distance of 5 millimeters. And also that this line is not vertical. It's not vertically beneath the center. It's also offset. It is vertical in orientation, but it's offset, and that's because it's the same vertical face that we see here. That this same vertical face all the way through, right? We don't see an edge separation here. It's the same line, so it's not going to be in line with the center. So I'm going to make another sketch on the front plane, and in this case I'm going to bring a line from this point here. We see that's where the face and the circle meet. Bring it to the circle, the inner circle, and I'm going to draw an arc very quickly here, like that, roughly like that. I'm going to draw a center point arc, again, from the same center, from this point to somewhere around here. Looks about correct. It's a bit difficult to see, I know, because of the body here, but it should be useful to have it, to show it anyway, just because that way we can use the references and connect this to that. And now I have a closed profile for the cut, but I have to define this here. And for that, I'm going to need a center line from the center, and just make it vertical. It doesn't have to be too specific. Just make it horizontal, sorry. From the origin, horizontal. That's all you need. And select this and this. Set the angle to, we'd set 120. Yes, 120. And click the center of the circle and the line and set that to 5 as we discussed previously. That's 5. That's correct. The whole thing is fully defined now, so I can go ahead and make another extruded cut. And once more, mid-plane, we're told this is 100 from one end to the other, so I can just select that here, 100. And that looks correct to me. Now there's only a few details left. Well, pretty big one is this cutout here and the edge that protrudes from it, and at the bottom we have the little lip that we see here. First I'm going to make, let's see, first I'm going to make the hole probably. So I'm going to start a sketch on this face. I'm going to make a slot because it's the same shape we're dealing with here. Looks something like this. And I can start dimensioning it because I'm just going to make the cutout right now. I'm not making the whole thing. We're told we have 50 in the vertical direction from one end to the other, so I can select one line and the other line, set that to 50 millimeters. And then from one end here to the other we have 72. And in this case we don't need to necessarily do the whole max thing. You can do it and it will work, but instead you can just select the midpoint from here and the midpoint from here, and it's actually the same thing because we're dealing with something that has a regular shape and an opposite angle. So that's 72, and that's that properly defined. We can make a cut. Again, just make it through all, goes to the whole thing really, so through all, don't need to specify a dimension that way. And I'm going to make another drawing on this face. And for this now I'm going to just draw basically a parallel oval or an offset oval that has 16 millimeters of separation from this one, and so that we can extrude this and this here. And for that, I actually don't need to draw anything else. I can just use the offset entity tools, and if I select a line, you'll see the offset entities tool just copies it and extends it outwards, like so. If you select the whole thing, you get another oval, same shape roughly, just extend it outwards, and we have to tell it how much we want to extend it, and that would be 16. We see the distance from one to the other, so that's 16 here, and that's that drawn. And again, because I don't want to fill in this hole once more that I just write the one here, I don't want to fill that in again. I need to copy this with the convert entities tool that I showed you before. Just select this, accept, and now when I extrude, I'm just going to extrude like a rim instead of filling in this thing again. So I can just make an extrusion, and if I don't feel like specifying the depth of it, I can just make it up to surface and bring it from the drawing plane to, in this case, this face, right? And you see, I don't need to specify the dimension that way. It just goes until it meets this, and well, looks correct to me. So I'm going to accept, and yeah, sure enough, it looks the way it should, I think. And now we're just left with the little lip at the bottom, and that we can also do. Well, we have to start a sketch here, and again, just convert or offset entities in this case from that oval, and see that the preview shows that it's going to draw it within because it has the reverse option here for some reason. I can just unclick it and now it's going the other way around, and that's the way I want it. But I want it to be, in this case here, you can see I want it to be 8 millimeters thick, the little lip that I'm going to make. So that's 8, like that. And again, I have to copy the line within with the convert entities tool. And in this case, we do have to make it blind because we want to specify the dimension, which is 5. Excuse that, 5 millimeters. And there you have it. That's the whole thing done.